Okay. So are you ready, class?
Yes.
All right. So let's start our class. Okay.
Yes.
Today we're going to see motion in two dimension. Okay, so we have learned about one dimension. Okay, free fall motion. One dimension we have two. Okay, you have learned about you have learned about one dimension, which is vertical motion. Okay, and we also have learned about yang horizontal motion pun kita ada belajar juga. Okay, kita dah belajar. Alright, so for constant acceleration, okay, so when we have a constant acceleration, we apply that four equation. So I hope that you still remember that four equation, since we are going to use that four equation for today's lesson juga. Okay. Alright. So for today's lesson, we are going to see projectile motion. Okay. So right. Okay. Okay. So projectile motion consists of two components. Alright. So we have learned about one dimension, X sahaja, Y sahaja. But in projectile motion, we have both. Okay. So we have vertical component. Alright. So which is the motion we always under constant acceleration, which is means that this motion always that object, okay, always move in a uniform acceleration, which is our gravitational acceleration, negative y, 9.81. Okay, and then we have horizontal component, right? So horizontal component where the acceleration equal to 0. Okay, also constant, no, I mean the acceleration is 0. Why? Because during the motion, okay, so it only involves, kejap ya, ada orang masuk kat ni. Saya pun tak faham. Awak ada link ni. Please saya kena accept juga. Sebab saya pakai link yang minggu lepas je ni. Tapi saya kena accept juga. Tak tahu kenapa. Alright, ada kita masuk. Okay. Mana ke? Okay. Alright, so motion with constant velocity. Alright, so apa maksud dia constant velocity? Alright, let's say we have this trajectory. So I show you this. Okay. Alright, so let's say we have a trajectory. Tak kisahlah bola, sepak bola ke apa ke. Okay. Alright, so make an angle. Okay, so the motion, okay, make an angle on XY plane. Okay, different dengan yang kita punya panggil apa? Free fall motion. Okay, memang totally free fall. Okay, why? Because dia naik lepas tu dia turun. So memang totally G lah. Totally negative G saja. Okay. For this case here we have an angle here. Okay, so the motion make an angle here. Alright, so at this point also we have an angle. Sekejap ada orang masuk lagi. Tak faham. Kita nak masuk. Okay. Alright, so here di bagi Alright, at this point we have different angle. Okay, so here we have an angle here. Alright. Okay, so even at the top point, okay, even the object at the top, at the maximum height, it still have X, but can you see here the direction is towards the X. Okay. So no direction sebab we agree that Vy at the 2 it will always equal to 0. But what is the factor, okay, that yang push dia untuk ke arah sini? Okay. So that is your Vx, your constant velocity. Okay, your velocity in x direction or your horizontal velocity. Your y here will always equal to 0. So masih sama dengan yang ni projectile motion. Free fall motion. Okay. So why free fall dia tak jadi macam ni? Why? Because dia tak ada Vx ni. Vx dia equal to 0. That's why the motion tu, okay, the pattern akan jadi naik dan turun. Buruknya. Okay, so that's why Vy dia equal to 0 and Vx here equal to 0. Okay, for case free fall. That's why dia punya motion naik dan turun macam tu. Okay, macam ni. Okay, so dia tak boleh push ke sini, ke arah sini. But for case projectile motion, the difference is, okay, so dia naik and then at the top ni, okay, yes, your Vy equal to 0. But you have Vx in this direction. Okay, so you have Vx in this direction. So that's the things yang cause that object, okay, to complete this trajectory sampai sini. Faham tak? So dia tak sama macam your free fall. That's a different lah. Alright. So why the acceleration equal to 0? Why? Because Vx mana tak boleh. Vx will have same value as the same as dia tak boleh. Same as the initial value. So kalau V not X di sini samalah dengan Vx di sini, samalah dengan V dekat top ke, samalah dekat Vx di sini, samalah dengan Vx di sini. But what the since this motion involve two component, okay, so we need to consider both. Okay, so here Vx always constant, but Vy they affected by the gravitational acceleration. So we have negative G. Okay, sebab dia in vertical, sebab G in vertical. So that's why dia tak affect your punya horizontal velocity. So dia it only affected the value for the vertical velocity, which is your at y component tu. So here what happened? So we have different value of Vy. Here we have V naught y. Here we will have Vy. Here Vy equal to 0. Here we have, okay, here we have, bila dah turun kita dah ada, kita ada Vy negative. Here also negative bila dia dah start turun. Understand? So your Vx akan always maintain. Okay, dari awal sampailah dia jatuh, you have only a value of velocity for X component. Okay, but for Y component, you are going to have different, right? So alright, so here, let's say we label it as APBQC. Okay, because we are going to derive the equation at this point. Okay, but that one is just saja. Okay, kalau, but I encourage you to use the original, I mean derive your punya case tu from your punya original equation. Okay, takut nanti awak terhafal yang salah. Right, so we have an angle there. So at this time, kita ada masa yang lain untuk sampai at point P, alright. And then at point B, which is, ni tak sama lah. Okay. Kalau same level, ini for case yang trajectory dia parabolic. Okay. Sekejap ya, ada orang masuk gini. Okay. Dah cukup kot. Ada seorang lagi tak masuk. Join kelas. Okay. Alright. So for case parabolic macam ni, I mean untuk yang straight macam ni, trajectory yang macam ni, okay, ataupun kita panggil parabolic lah ya. Simple. Okay, why? Because we'll see the example later where we find that dia macam yang apa free fall tu. Okay, tapi the difference is dia ada X component lah. Okay. Alright, so that's the difference. You have X component. Okay, so this angle different with this angle. Okay, so that's why the V1Y ni have different value. But V1X always have the same value. Okay, here negative V2Y, right? The angle dah different. Okay, so for the highest point where the ball can reach, okay, we note it as X, right? And then the point of the X, the maximum point that X make, okay, we label it as range, okay. So for case X component, you need to know how to resolve, okay. So balik semula. So yang ni I hope that you still remember how to resolve the X component. So we will use the macam biasalah. V naught cos theta. Okay. Y varies from one point to another point along AC. So we have V naught sin theta. This is how we resolve. Macam V naught X sekali je. At one time saja you need to resolve. V naught Y also one time je. Okay. You will use the same one. Okay. Because if you consider this one is your initial lah. Okay. Because your the rest you will get your punya final. Final is you get from the equation tu yang memang dah component dia. Okay, which you need to resolve lah. But you need to find the resultant lah. Okay, let's say we have point P. Still remember where is point P and Q? So point P and Q is at here. Macam yang kita tengok tadi lah gambar tadi kan. Okay, so parabolik macam tu. So point P kat sini atas sikit. Okay. And then point Q dia bawah sikit. So here is your point Q, right? Okay. So for S component, simple. Kita ada satu je. Memang that is your memang that is your Vx lah. So sama. Okay, nampak ni. So sama. V2X sama dengan V0X. V1X sama dengan V0X. So sama, tak ada masalah ya. Kalau awak tak nak kira balik kat sini pun awak ambil je pun boleh. But the difference will be on your Y component. Okay, for your Y component. Why? Because it's change time here. Nampak tak? Okay, V0Y sama. Okay, value of V0Y is still the same. Your gravitational still the same, but here what's the change? What's apa? The things that change the velocity is time. Okay, time. So time yang menyebabkan dia berubah sebab masa yang diambil, okay, time taken to for the ball to reach at this point, of course lah different dengan yang at this point. Okay, at least dia akan 2 kali ganda or more than that. Okay, macam tu. So that time affected your punya V2Y value. And if you use this equation, memang direct dapat. At point Q, here you will get negative Vy. Okay, negative Vy. So, what is the magnitude? What is meaning by magnitude here? This means that dia nak cari yang ini. Faham tak? Okay, so this is vector, right? Okay, so now you have component Vx. Awak dah cari tadi. And then you find your Vy. but the question is to velocities at point P and Q. So velocity, it have magnitude and direction. You need to always remember that. Magnitude and direction. So you need to use your punya apa ni? Your V naught X ni and your V1X and your V1Y to find the magnitude using this equation. Okay, after you find that, then you need to find the direction. So that you can label here what's the angle here. Understand? Alright, so simple macam tu. Still remember, masih. We are still using the equation for the vector. Okay, so tak ada apa yang pelik kat sini. Cuma, that's how lah. So that's why saya cakap vector very important for you lah. So you must remember or you need to know how to resolve the vector. So mana yang biasa guna cara sine rule dengan cosine rule tu better make better get familiar dengan yang resolution vector ni juga. Okay, sebab memang kita akan guna untuk yang motion ni. Right. And then at maximum height, let's see what happened. Alright, so ball reach the maximum height, point B. Okay, still remember. Okay, so we have this pattern. So this is your point B. Okay, kat maximum height. So what happened dekat maximum height tu? Alright, so again, your Vs akan always the same with your V naught X. So problem kita pada Vy. Tak ada problem juga sebabnya at the top Vy equal to 0. Alright. So y, we take it as equal to h. So use this equation. You may use this equation to solve this one. I mean, for case that you need to find the maximum height. So y here, kita akan replace dengan h. We get this new equation. Do you need to remember this? Don't need. You just need to know which equation that you need to use from the 4 equations. So kita alter, cuma kita tambah ni lah. Subscription y here and gx tu jadi y kat sini. And negative is come from your punya acceleration, negative g. Right? Time taken to reach maximum height. Okay. So to reach the maximum height, since we have information on this, I mean, we have information on that the velocity at this point is equal to 0. And since you also have your V naught Y, alright, so you can use this equation, or we simplify the equation, become this equation. Do you remember this? Don't need, but you must remember this equation. Even this equation will provide that in your examination, but you still need remember. Why? Because you need to because you will know, okay, which equation you will understand, okay. So because every equation ada dia punya meaning dia. Alright, so you need to know how to explain that equation. Contoh, like this equation. This equation is for velocity at this time. Okay, velocity at this certain time. Alright, so that's why we use this equation to explain that at the top point, okay, at the top point, this is the time that we use to reach the top point. Macam tu. Okay. Alright, so this one boleh ingat ataupun tak ingat pun tak apa, tapi must remember this lah. Must remember and must understand this equation. Alright, flight time. Flight time is sepanjang dia berada di atas udara tu lah. Berapa dia punya masa. So since tadi kita ada dah masa kat sini. Okay, since only apply for case parabolic sahaja ya yang ni. So dia akan 2 kali ganda. Masa dekat sini. Faham? Okay, sebab masa dia akan sama semua. Basically, why we can have this relation? Why? Because we move, bukan we move, that object move with a constant acceleration. That's why we can have that a value of time. Okay. Alright. So you can have this one, or you just simply times 2 by 2 your punya point. Time yang that one you already find just now. Alright, now we are talking about horizontal range. What is horizontal range? Again, okay, recall back the trajectory. Okay, so this is your range here. So that's your range. Means the maximum distance or displacement that for X component yang dia boleh buat. Okay, yang dia boleh buat. So again, don't mix up dengan yang X. So X also have the displacement. Uh, Y also have the displacement. So Y tadi dia represent sebagai H, okay, yang untuk X component displacement kita represent sebagai range for maximum focus parabolic. Okay, if not kadang dia panggil sejauh mana yang horizontal. Dia biasa dia panggil macam tu lah. Mudah. Why? Again, because it only have an equation sahaja. Satu saja. Inilah satu-satunya equation kepunyaan X komponen kita. V not XT. Alright, so masa, berapa lama masa? We can use masa, yes. Again, masa is scalar. So, masa yang menyatukan komponen X dan komponen Y. Okay, macam saya cakap, X dan Y terpisah. But for case projectile motion, okay, yang we use time to relate these two two component. Okay, to relate these two component. Okay, yang ni cuma dia buat macam ni. Yang ni delta T tadi ni nanti dia sebab dia masukkan yang tadi tu. Siapa pula ni? Mai lagi seorang ni. Okay. Alright. Okay. So when you get this, mana ke? Okay. When you get this one is from here. Here. Okay, so here. Alright, so maksud dia, that's mean that flight time lah. Okay. So to find the range, okay, so your V naught S, you need to time dengan your flight time. Okay, so maksudnya masa yang diambil untuk dia dari sini ke sini, where we can get from yang Y component tadi. So time relates, yang akan bantu kita untuk relate that two component yang terpisah ni. Okay, so again S and Y cannot mix up. Okay, but time yang akan relatekan dia. So maksudnya, okay, time yang digunakan, time here, okay, time flight here adalah untuk dia bergerak setinggi, dia bergerak dari sini kembali ke sini sepanjang ini. So that's the explanation for the time, right? Okay, so here simplified become this equation ke mana lagi equation dia? Using the trigonometry, so we get this equation for the R maximum. Okay, but quite risky to use this one. Okay, because only for case parabolic sahaja. Case yang macam ni sahaja ya kelas. Okay, case yang begini, sebab we have some types, okay, of panggil apa? Of projectile motion. So we have yang ni which is ada angle. Yang ni tak ada angle, totally X component, horizontally lounge. So maka dia jatuh dalam case ni. Parabolic pattern dia jatuh dalam bentuk ni. Ada angle kat sini, initial angle ada. So dia ada VY. Tapi bila dah ini maximum point, that's why VY here equal to 0. For case yang horizontally lounge. Nanti kita tengok contoh. Alright, so horizontal. Sampai pun. Ni dia. Okay. Alright, horizontal projectile, ball bearing rolling off and in table. Okay, so macam ni, dia jatuhkan. Okay, dia nak jatuhkan ball, dia rolling atas meja, then dia akan macam tu lah. So dia takkan jadi jatuh bebas lah. Why again, apa yang macam saya cakap, again, apa yang menyebabkan dia jadi bentuk macam ni, dan dia tak jadi bentuk macam ni. Why? Because we have the x velocity. We have x velocity at component x, which is akan always the same at every point sepanjang dia punya trajectory ni. Okay. So for this case, your maximum x is here lah. Okay. So and then your maximum h is here. Again, bila kata maximum height, you need to always remember that your Vy equal to 0. So apply tak untuk case ni? Still apply for this case also. So here bukan dia tak ada initial velocity, ada, but in x direction. What happened to Vy? Vy equal to 0. But kenapa tiba-tiba Vy boleh ada kat sini? Because it move with negative gravitational acceleration. So dia akan zero dan makin negatif. Okay, sebab dia negative acceleration. Okay, so that's why kalau atas boleh dapat Vy equal to positive, yang positif. Once they reach maximum, Vy equal to 0, after this, your punya tu akan negative sign. So kadang soalan akan tanyalah, adakah at this time that ball already reached the maximum point? So nak buktikan macam mana, you need to prove that you punya velocity tu at that time, I mean we focus on Vy lah, sebab kalau Vx memang takkan membantu kita lah, sebab Vy memang tu je kita tak boleh ubah dia dah. Okay, so you need to prove that your Vy equal positif ataupun negatif. So kalau positif maksudnya dia masih somewhere around here, which is dia tak reach lagi your punya maximum. Okay, before the maximum. So kadang-kadang soalan ditanya macam tu lah. So that the other way to ask you to find the ni, so bagi menarik sikit kan. Okay, tak adalah ayat yang sama. Cari velocity pada maximum point. Macam tu. So tak best kan. So kita buat macam-macam lah. Atau mereka kata adakah sudah pada masa ini sudah melebihi yang ni. Macam soalan tutorial kan. Kalau kita bagi ni banyak ni, adakah dia boleh berhenti dalam masa tu? Macam tu lah. Okay, so soalan dah pelbagai lah. We need to be creative because you also creative kan. Right. Okay, so again for this case velocity constant. So your x here again we will only always satu saja equation v not x. Time lah. Time yang kita guna untuk travel dari sini sampailah sini. Okay. V not y kat situ. Again satu benda lagi yang you need to remember. Okay, h here, yes, but again your height, your height of the table is positive, but again when we do it dengan velocity, kita ambil dia sebagai displacement. So bila displacement from here, so this is your origin, so below than this it become negative. So here you have displacement yang negatif. Tapi kalau if the question asks you to find the height of this table here, okay, so you need to put positive. Okay, but if the question asks you the displacement, okay, the displacement for y component, then you should put negative. Okay. Alright, so dia kata for this case we have this equation. Okay, so we might use this equation. Since dia kata time taken, the question ask you about time taken. So this equation ada time taken. G memang macam tu lah, tak boleh ubah. V not Y tadi yang kita Sama dengan apa tadi? V naught Y for case yang horizontally launched equal to 0. And your Y here again need to remember to put your negative sign here. Once you miss to put this one, you still can get time here, but that is not explaining the time taken for the ball to reach the floor. Okay, so itu akan menunjukkan yang dia dari ketinggian yang atas pula. Okay, so that's the difference. Okay, so macam yang ni dia ketinggian dia ke bawah. Okay, macam tu. Maksudnya dia jatuh, bukannya dia naik ke atas. Alright. So you can have this equation. Do you need to remember this? It's up to you. But this one you must remember. Okay, horizontal displacement, use condition below. Okay, let's say we have this case. Okay. Alright, so ball A. Ball A jatuh bebas. Okay, so straight vertical. Ball B, dia ada apa? Dia horizontally launched dengan Vx. Okay. But interestingly, the time taken is the same. Time taken for these two ball falling down here, okay, kita akan dapat pada masa yang sama. Why again? Because, okay, for case yang projectile and free fall, the acceleration is not on the Vx. The acceleration is pada Y component kita. Okay, so since Vy here equal to 0, same as this Vy here also equal to 0. So means that the motion walaupun lain dia punya path, okay, going to have same move with same acceleration starting from 0. Okay, and falling down with the same time at the same time. Sebab yang untuk yang ni dia cuma ada Vx. Okay, dia ada velocity in x direction. Itu yang menyebabkan dia jadi dalam bentuk ini. Okay, but dia tak ter-effect lah sebab sekarang ni kita fokus pada ya dia punya acceleration masih sama. So bila acceleration masih sama, starting from 0, so we're going to have that ball take the same time to reach the ground. Okay. So this displacement for velocity along AB is constant. Okay, again macam saya cakap, satu-satunya equation milik komponen X ialah ini y because the acceleration equal to 0. So awak nak masukkan dekat semua equation pun boleh, tapi at last bila kita simplify, only this equation saja yang kita boleh gunakan for X component Y again because the acceleration for X component equal to 0. Okay. Again, the things that we need to consider for case projectile motion is and resistance is negligible. Okay, then we can apply that equation because dia tak ganggu kita punya gravitational acceleration. So the gravitational acceleration will always be constant. Okay, so we can apply the projectile motion. If not, then cannot lah ya. Alright, so let's see example. Okay tak kelas? So far so good. Saya laju sangat ke? Boleh ikut? Boleh? Nak masuk example dah?
Boleh.
Alright, good. Okay, so for this example, okay, shows a ball thrown by Superman, okay, with an initial speed 200 meter per second and makes an angle 60 degree to the horizontal. Determine position of the ball. Ada banyak soalan kat sini ya kelas. So please take note. And the magnitude and direction of its velocity. So two things yang dia tanya kat sini. Satu, mana tadi? Position. When at time 2 second. At time 2 second, so kita tak tahulah. Somewhere around here, 2 second tu. Okay, sebab dia bagi ni trajectory dia. So 2 second is somewhere around here. Okay. Dia minta where's the position of the ball and the magnitude and direction. So let's see how to answer this kind of question. Okay, so at first we have the component of initial velocity. Since the initial velocity provided berapa kelas? 200 meter per second. Okay. So when we use cos 60, sebab the angle tadi make 60 degree, so kita resolve dia kepada for each component x and y. Alright, so for y component we get 173 meter per second. Alright, by using this, we're going to find the position. Okay, again, position kat mana? Position apabila dia dah membuat penerbangan selama 2 second. Itulah explanation dia. Okay. Alright, so for X, okay, so bila when we talk about position means you need to give both X and Y because dia tak fokus pada horizontal saja ataupun what is the height of the ball. Dia tak cakap macam tu, dia cakap position. So at first we find the X. So you already have your V naught X. So again at time 2 second, this is the X position dia. From point P. Complete macam tu jawapan dia. For vertical component, we will use this equation. Right? So again, we have this is your initial velocity you to masukkan. So time ni kita ambil dari mana? Sebab time ni dia yang request nak 2 second. So masukkanlah 2 second. So what happened to the y? 326 meter above the ground. Because this soalan nak position dan can you just leave your answer like that? No. Because the position must always shown in coordinate form, right? So B. The time taken for the ball reach the maximum height and calculate the value of H. Time taken, okay. Dua benda juga kat sini ya kelas. Satu time taken untuk maximum height. Another one adalah calculate the value of your height. Right? So, alamak, lupa lah. Saya pun dah lupa tadi. Okay, yang A tadi kita tak habis lagi ya. Silap pula. Yang A tadi kita dah dapat position. So now we are going to proceed to find the velocity at time 2 second. So at first your Vx again, ambil saja dia lah. Cuma kena cari Vy at 2 second. Masukkanlah 2 second. This again, this equation is used untuk cari your velocity at this time. So you use this equation. Faham tak? Okay. So we get this value. Nak tinggal macam ni je ke? Cannot. Sebab dia tanya velocity. Bukan dia tanya dia for each component. So we need to find the resultant. Find the resultant. And find the direction. Can you just leave it there like this? No, cannot. You need to explain the position of the angle. Okay, positive x axis anti clockwise macam tu. Alright, untuk B, at the maximum height, okay, at the maximum height, Vy equal to 0. Betul? So, time taken, kita boleh ambil dari equation ni. Again, at time, the velocity equal to 0, berapa masa untuk dia reach velocity equal to 0 tu? So we can use this equation and you get positive. Okay, time akan get positive. Kalau awak masuk equation ni, time dapat negatif, something wrong somewhere. Tapi kalau awak dapat negatif time tu daripada quadratic equation, then masih okay. Because you can choose positive. But if you masukkan dalam this equation yang linear, tiba-tiba your time dapat negative something wrong somewhere lah. Okay, so need to check lah. Right? So your maximum height, simply use your time that you have find tadi. Okay, and then your H. So tengoklah H dia positif ke negatif? Positif. Sebab dia case parabolic macam ni. So this is your H, which is above the origin kat sini. Okay. Right. And then the question asks you to find ini jauh sangat ni. The horizontal range. The horizontal range is yang ni lah. Okay, again horizontal yang ni. Okay, jom kita cari. Okay. You see horizontal range. So here, okay, macam saya cakap tadi, time that relates your punya X and Y. So tadi you have information on berapa sampai sini. So to find time untuk dia turun bawah balik adalah kali 2 dia. Okay, understand class? Alright, so kali 2 dia. So kita dapatlah masa untuk dia sampai sini. Alright, so now we proceed to find the X using that time. Okay, that time yang mana kita times 2 masa yang diambil untuk sampai ke maksimum tu. So we get this value 3520 meter. Kita pergi pula pada soalan E. The position of the ball and the magnitude and direction of its velocity at point Q if the ball was hit from a flat top hill. Okay. Dia kata was hit from a flat top hill. This time at point Q 45 second. Bila 45 second tadi kan? Mana tadi? Okay. Alright. 45 second is already more than this. Maksud dia, that's why ada kat gambar tu. Okay, 45 second. Yang ni kan 35 kat sini, tak kat sini je. So 45 is mesti somewhere around here. Okay. So dia nak velocity. Betul lah. D ke E? Okay. So your D. So the velocity again your X component ambil sahajalah your initial. So your Y component again untuk cari dia pada masa 45 adalah this velocity. So kira je lah. Dapatlah velocity dia again. See, you can see here automatic you get negative value. So maksudnya dah arah ke bawah lah Vy tu. Nak tinggal macam ni ke? Cannot. The question ask you to find the velocity. So completekan. Find your magnitude. Find your direction. Want to leave it like this? No, you cannot. So you need to give the position for the your punya angle. So since ada negative here, negative showing that here dia arah ke sini. Ini yang 60 degree. Bila ini yang 60 degree, maksudnya bila kita nak ambil dari positive x-axis ataupun anti-clockwise yang urutan yang biasa, okay, yang biasa kita buat adalah here lah. Okay, so this is 300 degree from positive x-axis anti-clockwise. Macam tu. Ataupun bolehlah awak nak guna awak punya apa? North. Kejap. Ni west. Ni south. North east. Okay. So awak kata 60 degree south of east. Masih valid juga. Alright. So, kenapa saya buat macam ni? Tadi dia nak kejap. Oh, tadi dia nak D ni Oh, tadi saya terskip D eh. D dia nak velocity. Oh, velocity dekat ground eh. Okay, saya dah terlajak pula. Okay, so E yang baru 45 degree, 45 second, sorry ya kelas. Okay, so E ni position of the ball when T equal to 45 second, sama juga macam step yang soalan A tadi. Buat macam ni, and then you get your buat X, and then you get your Y. So masukkan dalam coordinate macam tu. So nampak tak Y dah negatif. Maksudnya dia dah lebih kita punya parabola ataupun lebih daripada dia punya original point. So dia dah bawah sini lah, somewhere around here. So that's the coordinate. So from here kita tahulah memang spesifik macam ni. Faham tak? Alright, so 45 second velocity pula kena cari sama step dia. Ulang balik step yang nombor D tadi pun boleh. Okay, cuma tukarkan masa saja. Macam tu je. So memang kita boleh tanya banyak soalan. Cuma the konsep masih sama. Cari yang komponen X, komponen Y, magnitude, direction. Macam ni. Okay, so when you get your angle, what happen? Again, you need to explain your angle here. Okay. Now we move to second example. Okay, transport plane traveling again ya. Every time you want to answer physics question, please always remember to draw. So draw macam ni. So macam ni. Ini untuk case yang horizontally launch. Okay, horizontally launch. Okay. Okay, so A, flight time of the parcel. So masa yang diambil dari sini sampailah sinilah.
Madam,
Ya, kejut saya. Ya.
yang bahagian bawah tu macam kurang nampak sikit. Dia macam terpotong.
Oh, kenapa? Sekejap. Ni dah besar dah. Kenapa ya? Kau view ke? Okey tak? Ke sama je? Nampak tak?
Better.
Oh ya ke? Ke sikit. Tapi lepaslah. D ni nampak?
Apa?
D tu nampak ni yang bawah ni.
Tak nampak lah.
Oh tak nampak dah. Okey. Kejap. Okey. Naik kejap lah. Okay. So kita tengok untuk case yang horizontal ni. Horizontally launch. Okay. So the different dengan macam saya cakap, different dengan free fall sebab yang ni dia ada velocity. Okay, so velocity of this jet ni dia kata constant velocity at an altitude 300 meter releases a parcel. So biasa student akan fikir dia jatuh bebas sedangkan dia ada acceleration, velocity. So dia takkan boleh jadi jatuh bebas sebab jatuh bebas Vs equal to 0. Okay, so calculate flight time of the parcel. Flight time of the parcel from here to here. Okay. So parcel velocity, plane velocity 50 meter. 50 meter per second V naught dia kan? Okay, so V naught dia memang dah V naught X lah. Okay, sebab tak ada angle. Right, thus V naught X dia macam ni lah saya cakap ni. V naught Y dia at this time is 0. Okay. So vertical displacement is given by negative 300 meter. Again need to include your negative sign ya class. Alright, so the flight time. Okay, so we can use this equation sebab kita nak cari time kat sini. Okay, so the information that we have is ni. Sebab bila kita ada ni tadi yang Vy kita cuma ada yang ni initial. Final ada. So that's why kita tak boleh guna equation yang lagi satu tu. Okay, so kita terpaksa lah juga guna equation yang ni. Okay, sebab kita ada information on displacement here, the height. Okay. So your height here negative 300 and then T here, so we get 7.82 second untuk the flight dari sini ke sini. Boleh? Alright, so B, component of velocity of impact of the parcel. So impact ni basically dekat sini lah, dekat point dia jatuh tu. So macam-macam macam-macam cara, bukan cara. Okay, macam-macam statement. Macam-macam ayat dia boleh buat. Macam yang ni dia cakap impact. Velocity of impact. Maksud kat sini lah. Ataupun dia kata before strike the ground. Okay, kat sini juga. Ataupun dia kata at the maximum horizontal point pun boleh juga menunjukkan. Kena cari point yang kat lepas dia turun tu. Okay. Alright, so Vy equal to V naught Y minus GT. Okay. So here you just simply need to masukkan je lah. Substitute your punya time that you have find tadi. We find the velocity pada bila kita dah buat masa sebanyak ini. Okay, so again automatically you will get negative sebab apa? Bila kat sini memang dia turun, kan? Negatif lah. Memang akan dapat negatif lah. Again, jangan tinggal jawapan macam ni je. Masih tak complete. Sebab apa? Sebab velocity dia ada both component. It have two component X and Y. So find the magnitude and direction. Okay. So from here you get ni. Nampak tak ni? Ni negatif, ni positif. So explain which quadrant dia ataupun explain macam ni pun boleh ataupun macam saya cakap tadi nak buat apa lukis pun boleh. Kalau dah memang tak boleh sangat nak ingat east west semua dah tergabur habis, anti clockwise ke clockwise pun dah tak boleh ingat, lukis je lah. Okay, pun boleh. Okay, at least you have an effort. Okay, tapi biasanya kita sebab bukan soalan lukis, biasanya kita nak statement. Macam tu. Tu je lah masalah dia. Tapi kadang kalau ada lukis tu, kita nampak lah your effort to explain which one is the position for the angle that you give to. Macam tu. Distance from X, so point of impact D, dia nak X component lah. So ada masalah? Tak ada masalah sebab kita dah ada time. So masukkan je lah time dia, initial velocity tu memang terus initial velocity times the time flight time tu pun boleh sebab kan saya kata time yang relate that to component. Okay, so maksudnya time yang guna untuk buat yang tu pun sama dengan time yang untuk dia travel sejauh itu. So that's the explanation untuk time tu lah. Okay, so dah masuk exercise. So boleh try exercise ni if you have time. Okay, ataupun dah buat tutorial tu, fahamkan tutorial, buat ulang, buat 2-3 kali sampai awak betul-betul boleh buat sendiri pun dah cukup. Okay dah sebenarnya. Tapi kalau nak